Today we will just refresh our water supply design calculation.
Yeah, sure.
Okay. See, this all the study material have been shared with you before. So we started with the source of water, like water where comes from. Okay, what is the type of water? What is the quality
Yes,
of water that we have discussed? Okay.
that's the
Then what are
description.
the codes and standards will be used for the water supply design, right?
Yeah, yeah.
Okay. Then we have seen before that architectural package how each and every space planning is done. Okay, like
Yeah.
different spaces, that also we have seen. Okay, then we have seen
Yeah.
that various plumbing fixture. Okay, what are the
Mm,
various plumbing fixture in our building? Say for example, if you go to IPC standard, you can see
mm,
that there are kitchen sink, there is a lavatory. Okay, there is a
mm,
service sink, urinal, wash
mm,
basin, water closet.
mm.
There are many fixtures. Okay, so what
Yes,
I'm
yes,
saying, when you go to design any architectural project, you have to try to find out where is the wet area, like toilets, like kitchen area. Okay, then you
yeah.
have a cooking, wherever the cooking areas or bakeries. Okay, like you have to find out wet areas where you really need a water, correct?
Yes.
Okay, so basically based on that the fixtures, okay, like you have a different fixtures. Based on that fixtures, you are going to calculate WSFU first.
Yes,
So what is,
yes,
whether it is a cold water you require or hot water you require, or you require a combination of both, then you have a value here. Okay, then you have a
yes,
different type of water closet, you have a different type of washing machine, you have a different type of urinal, you have a different type of shower head. Okay,
mm, yes,
different type of kitchen sink. So the first differentiate is what you have, a private or public. That depends
yeah.
upon your architectural building. What type of building you are designing. If it is a residential, private. If it is a shopping mall, public. Right? So
Yes.
based on that, you are going to decide the WSFU values. So once you decide the WSFU value, you are going to add all the summation of all the WSFU value. Clear?
Yeah, sure.
Okay. So once you get all the WSFU, then based on the WSFU value here, this is the IPC code table for estimation demand. Okay. So based
Yes,
on
yes.
based on the WSFU value, you can able to calculate the flow rate, right?
Yeah.
You have
Sure.
any doubt till that?
No. No, see, for example, I want to just specifically see we
Yeah.
have said that water supply fixer unit for the WC
Okay.
private with flush tank it is 2.2, right?
Yes.
Then for the wash basin, what is the lavatory? What is it? Private it is showing zero point 0.7,
Yes.
0.7. Then for the shower head with the private it is showing 1.4, right?
Yes.
Then what about the hand spray?
Hand spray, actually it is not here. Okay.
Yeah.
But we actually based on the flow rate, okay, based on their experience, we can
Yeah.
decide what will be the flow rate. Okay, but based on my
Mm.
experience, I will tell you that we go with the 2.5 DFU, sorry, WSFU for the hose beep.
Top 2.5
Yeah, 2.5 WSFU.
WSFU. Okay. So
Okay,
then
this
it
is
is totally,
based on our experience with the say for example when you operate a hose beep, okay, like a
yeah,
wash spray, you can able to understand that what is the velocity, what is the flow rate. Okay, based on
yeah,
your manufacturer also tell you. See, if suppose some fixture is not in this listed, so what they are
yeah,
saying, for fixtures not listed, the load should be assumed by comparing the fixture to one listed using water in similar quantities and at same rates, right? Similar
okay,
rates. Okay,
yeah.
and also you can verify with the manufacturer. Okay, you can check with
Yeah.
the manufacturer what will be the WSFE or what will be the flow rate. Okay, when you have a
Okay.
hose beep, you can check with them what will be the flow rate. So they will give you the flow rate. Assume that they are
Mhm.
giving flow rate for uh, assume that they are giving flow rate like 5 GPM. Okay,
Yeah,
so you
okay.
can say that you can fix your value. Okay, hose
Yeah.
beep will be
See,
2
for example,
WSFU.
for this toilet, I have given the WSF total value 6.8. So we have to consider at 7, right? And the gallons per minute is 11.8, right?
Yeah, 11.8. Yeah,
Demand,
yes.
demand.
Yeah. You can able to
11.
calculate the exact value by using the
Yeah,
equation. You know that the interpolation equation.
yeah. Okay.
Okay, say for example, if it is 6.5, if you know two value, you can able to calculate the third value. You know that, right?
Yes. Yeah.
So you can able to do the interpolation and you can find out the value. Okay,
Yeah.
clear?
Now for this one, I have got a value of 6.8. For
Okay,
example, WC 2.2, wash basin 0.7, shower 1.4, and hand spray 2.5. So I
okay,
got 6.8. So
okay.
6.8 is the our
See, remember there is a interpolation calculator. If you
yeah.
go to this interpolation calculator, okay,
Mhm,
I know that there is a 6 value available, 7 value
mhm,
available, and what is 6? It is 10.7, right? 6 is 10.7.
10.7. Yes, yes.
Okay, 10.7.
Okay.
Okay, and what is the what is that 7? 11.8.
11.8. Yes.
Okay, what you want to know? You want to calculate 6.7,
6.7.
right? So calculate, you will
6.7.
get the value here.
Okay.
This is the
11.7.
linear
Okay.
interpolator. Okay.
Well,
Okay. Assume I want to I want for 6.5.
okay.
Okay. Actually, you have to make it blank. Okay. Then you calculate. You will get this value. Okay.
Okay. Yes, yes.
Okay. Assume that you calculated like 52, for example.
Okay.
So
Yeah.
you know 50, you know 60, you know what is 50, 29.1, 60, what is 32, and for 52 you want to know. So you can do using that interpolate calculator, you can calculate 52. What is the value? Clear?
Okay. Yeah. Yeah. Now, if
Okay.
now now I got this one demand is 6.8, right?
Okay. Okay. 6.8, you got
And
the value, right?
yeah. Yeah. I
By
mean
using the
7 is
interpolator
so.
calculator, you got the value. So this is
Yeah.
the
But
GPM.
okay, that is 11.7 is 11.8 GPM. Okay. What about now? We have to go to the pipe sizing, right?
Yes, pipe sizing. Now, for example, I will tell you how to do the pipe sizing. Okay. So
Yeah.
there is a
Yeah. Yeah.
table. There are different material table. Why there is a different table? Because you have a different surface friction,
Yes.
right?
Yes. Yes. Yeah.
Say
Yeah.
for
Yeah.
example, if it is a plastic pipe, smooth. If you are
Yeah.
going with a GA pipe, it is little bit hard. So
Yeah.
you have
I am
a
going for the CPVC pipe,
okay. CPVC is nothing but plastic pipe, right? So
plastic pipe. Yes.
plastic
Yes.
pipe is nothing but fairly smooth pipe,
Fair.
or
Yeah.
or you can say that fairly smooth pipe. You can choose this one, right?
Yes. Yes. Yes.
Okay. Now, if you go to this particular chart, okay,
Yeah. Yeah.
you calculate the GPM, right?
Yeah. Yeah.
Okay. Remember, in sometimes back, I told you that as per the IPC standard, for the velocity, the appropriate velocity for the water supply will be 4 FPS to 8 FPS, right?
Okay. That
Okay.
will be constant. That we have to keep it constant or what?
Yeah, that is keep you have to keep it constant because that is the velocity you
Constant.
are going to use it for the water supply.
Water supply. So this
Okay.
velocity, from where we can achieve this velocity?
No, this is the standard velocity from from the code should be 4 to 8 FPS, right?
Okay.
Okay, now you calculate how much the flow rate 16 point or 11 point
No,
something,
no,
right?
11.8. I got 11.8.
Okay, now
Yeah.
11.8, what you have to do? You have to go and you have to match with the velocity 4 to 8. So I'm going 6 in the center, right?
Yes. 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 Yes.
So this is 6 feet per second because why I'm going with the center? Tomorrow I have a cushion like I can go below or I can go above. Okay, if I go
Yeah.
4, what will happen? Sometime if it is very say for example I'm selecting the next pipe size, what will happen? The velocity will be reduced, right?
Reduce. Yes. Yes.
So then it will go less than 4. So which will be very lesser velocity. Okay, that means
Okay.
you will not get proper pressure. Okay,
Yeah.
so if it is go more than 8, what will happen? There is a more pressure, right?
Yeah. Yeah.
Remember when you have some experience when you go and use lavatory or wash basin. Okay, when you open the tap, okay, for what will happen? You should have a proper velocity. If it is very low, you will take long time to hand your
Long time.
to
Yes.
wash your
Yes.
hands. If it
Yes.
is
Yes.
very
Yes.
high velocity, what will happen? It will splash on your face, right?
Yes.
So both it is not good. So you cannot go with lower velocity, you cannot go with higher velocity. So what is the optimum velocity, appropriate velocity? 4 to 8 fps. Okay, when I'm designing as a middle, I will go with the 6 fps, right?
6 SP. Okay.
Okay, so here I have chosen that 6 FPS. So what is the pipe size
Okay.
here? I can say that this is the pipe size chart. So this is 3 by 4, right?
3/4.
This is
Okay.
3 by 4. So this is
Yes.
which is nothing but above 3 by 4, correct?
Yeah. About 3/4. Yes.
So
Yes.
I'm going to use one velocity, right?
Yeah. One inch. 1 inch.
1
That is
inch.
inch.
I'm going to use 1
1 inch.
inch, right?
1 inch. Yes. Yes. Okay.
Okay. Now see what is happening when I use 1 inch. Where is where is my pipe? I'm somewhere here, right?
Yeah.
So now
Yes. Yes.
check what is the velocity now.
Velocity is 4 point something is
Yeah,
there.
so that is why I have chosen 6 so that I can
Yeah.
play with the 4 to 8, right?
Yeah.
So
Okay.
now actual velocity is 4 point maybe 1 meter per second, FPS, feet per second.
Yes. Okay.
Clear? So this is my pipe size. So what is my pipe size for this flow rate? 1 inch.
1 inch.
And what is the
So
velocity? 4.1 FPS.
so when you select 1 inch and the velocity is very low, I mean 4 point something means the pressure will be very less, right?
Very less, yeah. So it can be 4 to 8. So I'm within that 4 range, right? I'm within that
Yeah.
4 to 8. No,
Okay, okay.
yeah, I'm not
Okay.
going to 3 or I'm not going to 2. I'm in the range
Yeah.
of 4 to 8.
Okay, okay, okay.
Okay. So now
Yeah.
when I go down here, I will get the PSI value. How much? What is the PSI? Assume that it is a 4 PSI, right? This is the
4
friction.
PSI.
So by using
Yeah,
the
yeah.
GPM, I can calculate velocity. I can calculate the pipe size. I can calculate the pressure drop.
Pressure drop is okay.
So like 4 PSI per 100 feet of length.
Okay, yeah.
Is that clear?
Yeah, clear, clear.
You
That
have
4
any doubt?
PSI, can you just explain 4 PSI, 100 feet? What is the ratio? I
No.
mean,
See what I'm saying. What is that 4 PSI? Say for example, whenever you have a pipe length, right?
yeah, okay.
Okay. Remember, we have seen in the IPC standard as well. Okay. What is the pressure drop? If you have a 1 feet of the pipe, or
Yes,
you can say
okay.
that 100 feet of the pipe. If I
Okay.
have 100 feet, so let's say for example, this is the length 100 feet, right?
Yes,
So
yes.
100 feet of the length, I have a 4 psi, 4 pounds per square inch pressure drop. Right? There is a friction created. Friction means what? See, for example, whenever the water flows on the pipe, okay, it cannot flow in the same velocity, right? Say, for example, there is a velocity here. The same velocity you cannot expect here, correct? There is
Yeah.
a pressure. There is a slowdown because of the friction in the pipe material, right?
Yes, yes, yeah.
So that is the pressure drop. Okay, pressure drop means when the flow when the pipe when the water flows through the pipe, okay, it cannot flow with the same velocity. There is a velocity, different velocity here, and also there is a different velocity here, right?
Yes.
Or you can say that different flow rate. Assume that say for example, okay, there is a pipe here, right? Okay,
Yeah.
and you have a motor here, or you have a pump, okay,
Yeah.
and you have a same pump here, okay, and you have a short pipe here, right?
Yes, okay.
Do you think that the same flow will be here and the same flow will be here?
No.
No, because of the pressure, right? Because when the
Pressure, yes.
water passes through the pipe, there is a friction created within the pipeline. Okay, because it
Yes.
is a when it's a pressure creating, right? So what will happen?
Yes,
The
yes.
pressure keep on reducing. That means it will reduce the flow and it will try to maintain the lesser flow here, and it will maintain higher flow here because of the shortage of the pipeline, right?
Yes, okay.
So that is why whenever you go to FCU, okay, what will happen when you have a FCU? Actual FCU is like, for example, you have a 100 liter per second FCU flow rate, okay, and say for example 50 Pascal, 50 Pascal is the FCU pressure drop, right?
Yes, okay.
So when you actually install, when you put a motorized damper, when you put a damper, everything, assume that your pressure drop is 75 actual at site, but your FCU selected for 50 Pascal. So what will happen at the site? You will not get the proper flow rate at the discharge or the diffuser,
Yeah.
right?
Yeah, sure.
So that is why you have to properly calculate the pressure drop here.
Okay.
So if you have a
So
elbow, if you have a straight duct, straight pipe, you have a elbow, you have a valves, you have to calculate properly all the fittings. So how you calculate all the fittings? There is a table given here. So if you go to this table, you can see the table here. What is the pressure drop for the for the for the different pipelines? Okay, and for the different fittings. Okay, so there is a you can see here there is a pressure drop, pressure losses in the different valves, different fittings, ball valve, gate valve, butterfly valve. Okay, different fittings like elbow or T branch. You have a different pressure drop here. It is given here. So you have to calculate that pressure drop to size the pump sizing. Okay, so that one, if
yeah.
you start practicing, then you can able to understand. Okay,
Yeah,
how
sure,
to
sure.
apply the value, how to take the value. So you may have some doubts. We can discuss that values, right?
Yeah, sure. Yeah.
So that is the way you calculate your water pipe sizing. Okay, and this also there is a equation to calculate the water pressure drop, like Hazen Williams and Darcy Weisbach Williams. Okay, so we can go through this step by step. I don't want to rush everything. Okay, so just try to practice yourself what WSFE value, how to calculate the flow rate, how to calculate the pipe sizing. Practicing this part, then we will go to next part, how to size the water hammer arrestor, how to calculate the demand. Okay, how to do the water tank sizing. We will step by step we will calculate.
Okay.
Okay. Yeah.
Now, as per this one, 11.8 GPM, you have selected 1-inch pipe, right?
Okay. Okay.
1-inch pipe. This is the header pipe, right?
This pipe can be anywhere. It can be header
Anyway,
pipe or it can be branch
no,
pipe.
but my question is, see, for this 1-inch pipe, and we have a flow rate of 11.8 GPM, right?
Okay.
For all these fixture units. So for the
Okay.
distribution, for when it comes to for the WC, for the distribution, the
Okay.
WC outlet is half-inch, right?
Yeah, yeah,
Half
that
inch
is
or
see. When you see this particular same code in the
mm,
IPC,
yeah.
each and every fixture, what is the size also it is given here.
Mm-hmm. Yeah.
Can you go to this particular one? Minimum size for fixture water supply. You have a
Yeah.
different fixtures. This is the fixture pipe size. Say for
Yeah.
example, this is
Fixture.
your water
Yes.
closet. This is the water
Yeah.
closet, and this is
Mm.
your fixture pipe size. So this particular pipe size will be same as this one.
Yeah,
Okay.
that is what
So
I'm
if you have a
asking. Yeah.
multiple pipe size, this is your main header. So this pipe
Mm.
only we calculated now.
Yeah. 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 Yes. Yes. Yeah. From the header, we have to drop the pipe and reduce it, right?
Yeah, reduce it. Yes, reduction will be same as the fixture size. The fixture size
Fixture
will
size.
be same as this
So,
size.
so this reduction from where it will be the reduction in the connection point, or where it will be the reduction?
No, when you have a branch line, you will take a
Yeah.
tapping, right? You will
Yeah.
put a
Tapping.
T
Yeah.
T and you will
Yeah.
take a tapping, right?
Yeah. That tapping, how much it will be the pipe size?
This pipe size will be assume that 20 mm, okay?
Yeah.
And this pipe will be same as this fitting. Say for example 12.5 mm, or you can say 20 mm, right?
Oh, this is for 20 mm. Yeah. Yeah.
You assume that 20 mm. Say for example this is half inch, 15 mm, right? Or
Mhm. Yeah.
12.5 mm. So this will be
Yeah.
12.5 mm.
12.5. Okay.
So this is
So
your fixture.
what are the pipe size as per the fixture this type only, right?
Yeah, fixture
Fixture
pipe
head.
only. Yes, yes,
Fixture
yes,
only. We have to drop that one. So
yes,
our header
yes.
will be 1 inch, and will be the fixture unit. If it is half-inch, then we have to provide the half-inch reducer,
Half inch,
right?
yeah, yes, yes,
Reducer.
yes. Because this
Oh,
main head pipe size for 2 3 fixtures, not one
two, three
fixture.
fixtures. Yeah. Yeah. Yeah.
But per
So
fixture
the
you have to match with that fixture size.
uh, so in the header, the pressure will be maintained as per the 4 GPM or something like that,
Yeah,
or
4 FPS. That is also
4
given here.
FPS.
Can you see
4
this
FPS.
value
Yes.
here?
Yeah. Velocity at 4 feet per second. 2. 2 GPM, right?
Yeah, this is the 2 GPM, 2 5 GPM.
To 5 GPM.
See,
Uh-huh.
assume that now remember we calculated 1 inch pipe, right?
Yes, yes.
And what was the flow rate?
1-inch pipe flow rate is 11 point GPM.
So, can you see this range? Starting
Yeah,
from 10 to 20 GPM, correct?
20 GPM. Yes, yes, yes.
So, this is the range.
Range. Okay.
Got it right?
Yes. Yeah, yeah. Okay,
Okay.
okay.
So,
Yeah,
can you
yeah, yeah.
start practicing, please? Because you are practicing BIM, I understand, but just take 15
Yeah.
minutes, 20 minutes just to go
Yeah,
through
sure,
this
sure,
one,
sure.
and you will
Yeah,
get
yeah,
some
sure,
idea.
sure.
Then
Yeah.
also try to ask some questions in the
I will ask.
WhatsApp
I will
group.
ask. Definitely, I will come to you. These are
Yeah,
the
not
doubts
that.
I am.
Our group. Ask in the main group, main plumbing group. Okay, I made
Main
the
plumbing.
group so that everyone can. It will be helpful for this
Yeah,
one,
yeah,
right?
yeah, yeah, yeah. So
Okay.
do you have any table showing that inch, for example, 1 inch 25.4 mm it is showing, no, like this half inch, how much it will be? 20,
12.5.
20
12.5.
half inch,
Yeah,
12.5.
12.5. Yes.
That pipe is available.
Yeah,
Half
it is
inch,
available. Yes.
it is
It is
available.
like it will be like a flexible pipe. You know that flexible pipe, right?
Ah, okay, that is flexible. That I mean,
Yeah.
in the okay, okay.
You
PEX
can say
pipe, you
that
mean
PEX pipe.
side
PEX
pipe?
pipe. Yeah, PEX pipe.
Oh,
Yes.
okay, okay. That PEX pipe connection also it is different, right?
Yeah, it will be flexible pipe, right? Remember, you have seen
There,
urinal, for example. Okay, that
yeah.
connection will be flexible. It will not be fixed pipe.
There will be a manifold or something like that.
Yeah, manifold. Like you remember,
Mhm.
whenever you see that in your fixture, that they
Yeah.
will be connecting with a small flexible pipe.
Oh, okay. Yeah.
Okay.
Yeah. Okay. Okay. Actually, I have to sit with you. Then only
Yeah,
I
just
have
to
lot
start
of
with that.
doubts.
See, this is yeah, really when you start practicing. See, we are not giving you time limit, right? You can practice
Yeah.
like
Yeah.
when
Sure.
n
Sure.
number of
Sure.
times. So start
Sure. Sure.
practicing. Then we will discuss about till you make sure that you know the complete water supply design. Till the time we will practice. Come back with
See,
me
if
your questions.
and one more thing I want to ask you. For example, one floor. we have 12 toilets. Okay. So that one for the one particular that floor, we have to total all the WSFE value, or how it
No,
will be
yes,
the.
yes, yes. See, for example, assume that this is your particular floor. Okay, this is your floor. Okay,
Yeah,
and
yeah,
this is your another floor. Okay,
yeah,
this is your
yeah,
another floor. Okay, then you
yeah.
have a riser pipe. Okay,
Riser,
so
this is the diameter.
when you have a branch to this particular pipe, you will add
Mm,
all this WSFU in that particular floor. Then this
mm.
particular pipe size will be designed for all the WSFU.
Okay, okay, okay. Yes, yes,
Then
yes.
this particular one will be calculating for all the WSFU. Okay,
See,
then
for
after that
example,
all WSFU will be coming down. Okay,
then the pipe size will be, the diameter will be very high, right?
yeah, it will be very high. Yes.
Uh-huh.
If you
So,
see some of the project, if you have a
mhm,
long water supply, you have a 100 mm, you have a 150 mm,
mhm.
200 mm sometime.
Okay. For 100 mm means 4 inch, right?
Yeah, 4 inch. Yes, yes.
4 inch pipe. Okay,
Yeah.
okay. That PPR is available. PPR pipe is PPR or
PPR, yes, available. Yes, PPR,
PPR.
HDP.
Uh-huh. Okay, okay.
Okay, if you see
That,
that infrastructure, remember when
mm,
you see the infrastructure outside, there is a
yeah,
like coming from Deva or suppose some
yeah,
authority. You have a very
yeah.
big pipe size. You remember when you see in our
Mhm.
country, you have seen that concrete pipes where they were
Yes, yes.
installing on the roads.
Yeah, yeah, sure.
So
I
what is
have
the
seen that.
diameter? The diameter is approximate like 500 mm, 400 mm, right? Which is coming from the
That,
authority.
yeah, that black pipe and all, right?
Black pipe, or you can say, yeah, black pipe. Yes, you can say like that. Yes.
Okay, I have
Okay.
seen that one. Yeah, yeah.
Yeah. So this is the way to calculate the pipe sizes based on the type of fixtures, based on the type of the flow, velocity, pressure drop, everything. Then you can able to design your piping system for the complete water supply. Clear?
Okay, okay. Yeah, clear, clear, clear. Yeah, yeah.
Yeah.